Ya. Kok merah-merah kacang sama begitu?
Kan follow mami apa? Kita yang follow mami. Daddy, Daddy. Even though Daddy don't give you, please Daddy too.
Hug you, Daddy. I hug you. Nah. See you, Daddy. See you.
Targetku sudah lain, Mama. Tidak mau lagi kecil. Hello, Austin and Yankin. Can you guys hear me loud and clear?
Yeah.
Yes. Okay. Good, Austin. And sorry, Yankin.
Recording in progress.
Okay, you got muted. Okay, Austin. Good. Right. Okay. Austin, give me updates while you set up.
Hello?
Oh, yes, Yankin. Yes. Can you hear me? I can hear you.
Yeah.
Good. All right. With the Jamboard, yeah, guys. Yeah. Austin, give me some updates, please.
What kind of update?
What's happening in school, the topics and everything.
For maths, I'm starting on Maclaurin.
Oh, really? Okay.
Yeah.
Maclaurin is new for you. Sorry, let me confirm that. Maclaurin
Yeah,
is
it's
new.
new.
Okay, cool. All right. And then?
Then for physics, it's DC circuit.
Are you in potentiometer for the DC circuit?
Yeah.
Okay. If there is any confusion on potentiometer, I want us to discuss about it because that's the important part.
Yeah.
All right. Anything else?
In the song.
You sound tired though. What's happening?
Oh, I just woke up.
Right.
I just got home from school, so I took a short nap.
Which is, I like that a lot, but that means you haven't had dinner.
Oh, I had dinner already.
Okay. So are you sure you'll be groggy for a while only? Are you sure? You okay?
Yeah.
All right, let's see what happened. Okay. Rankin, for your previous question, I haven't decided. I'm still a bit confused with it. Right.
Right. A teacher, I think she went through in class because I'm not in class. So.
Yep.
So basically what she said was because let me just show you the notes.
Yep.
This section. It's on the screen now.
Yep, I'm seeing it, and I'm also saying, okay, yes, Yankin. Right. Austin, you.
Yeah. So,
right.
So because there's a p orbital overlap with the Cl atom and the benzene ring, and the electron of the Cl atom will be delocalized into the benzene ring.
In the question, that means it's not the benzene ring, but the double bond.
Yeah, so the double bond, then she used.
The double bond has pi bond also, man.
Yeah, then is that not?
So the pi bond will overlap, or the pi bond of the double bond overlaps with the pi bond of the Cl.
If the p orbital is Cl. Yeah.
No wonder they mention resonance. No wonder.
Yeah, I still don't know what resonance is, but I guess that's resonance.
Never mind. Don't talk about resonance unless you have to. You do not have to evoke resonance to understand what she's saying. You don't have to.
Okay.
Right. You do understand what she's saying.
I think I can accept it.
Okay. All right. Now, just if you close this page, this overlapping thingy, the P of the Cl overlapping with the P of the double bond, right? What is the net result actually? Can you? Do you have it? Do you have it in your?
It'll be a stronger CX bond, I guess.
How does overlap in your mind? I know the sentence here is nice, but in your mind, how does overlapping make it stronger compared to overlapping?
Because the electron delocalized, after it becomes the way I thought of it was it becomes part of maybe kind of part of the benzene ring. Then the question says what partial double bond. So I guess it's if the bond becomes strong, the bond between the Cl and the connecting C of the benzene ring, or in this case the C of the double bond, will become stronger.
Right.
There's another layer. There's another layer of there being a low partial positive charge with a carbon attached to the halogen as well. So I guess there's that. But other than that,
All right. All right. Okay, if I were to build on what you're saying, just to confirm, right? So it's as if it is no longer a single bond. It's more than a single bond. Put it that way.
But it's not a full double bond.
Correct, which is still stronger, right? And then, or we can say that the pi bond becomes part of something bigger than itself, right? That's the overlapping. So being part of something bigger than itself, in general, does make everything stronger. Everything which is part of that thing, right? Okay. You may argue that means the double bond is weaker, but usually they don't cover that, at least not at this point. At this point. So you may go to that direction somehow, somewhere in some other questions later on. Okay. So as long as you understand that's fine. Okay. Okay. Right. So I'm seeing your question, but let me just confirm with Austin first. Austin, do you have a question, or you're just checking the learning accounts?
I have a question.
Right. Let me just see your first question. Curious what that is.
Oh yeah.
Again, Yankin, don't wait for me. Do something else first.
Yeah. Okay.
Okay, I'll take a picture, Austin. All right. Okay. Okay. I haven't seen your Jamboard though, so would you please put that in? Do you have it, Austin?
Yeah, send it ready.
Okay, so yeah, sorry. Okay. So I'm putting it in your Jamboard. Okay, that's a bit slow. Yeah, there you go. All right. Okay, so what is your question on this, Austin?
I don't know how to do question 6.
That means how to start.
Yeah.
All right. So I noticed that this is a reasonable, okay, a simple circuit. Okay, okay. Calculate the volt. You mean part A? You mean part A?
Yeah.
Is
I
the
keep
resistance?
doing, but I can't get the answer.
Is the resistance of the voltmeter disturbing you? Is that the issue here?
I mean, I tried to use the potential divider formula, but it doesn't work. Yeah,
because the potential divider is not a formula. I wish, because you're now JC2H2, you shouldn't think of it as a formula. You shouldn't. Potential divider simply means the potential is divided according to the ratio of the resistance. That's just how they work in a series, right? Okay. Now, the way you divide it, the way you divide is between the 1.5K and the 2K. Am I correct?
Yeah.
That would be your problem, because the voltmeter is real. It's not ideal. The voltmeter now has a 1K ohm. You should consider the 2K ohm with the 1K ohm.
Yeah.
You did that. So tell me, what is the total of the 2K parallel to the 1K?
I calculated it was.
Let me see how you type. Let me see how you type. I want to see how you type. Okay, I don't like how you type. I don't like how you type. Cancel everything. Cancel everything. I don't like how you type. I don't like how you type. So this, I'll teach you how you type. First of all, just use 2. Press 2. Sorry. I'm sorry. Bracket. I'm sorry. Bracket. I'm sorry. Bracket. Bracket. 2. Press the -1. X minus 1. X minus 1. Too slow. Cancel. There's a dedicated -1 button on top. Below the mode button. Below the mode button. On the left of the factorial button. There you go. Okay. Plus 1 minus 1. I mean, 1 minus 1 is obvious, but plus 1 minus 1, right? And then bracket everything -1.
Yeah, I wanted to do that just now.
Oh, no, you use a fraction just now. It's slower.
Oh yeah, I did 1/2000 plus 1/1000.
Correct. But this is much faster. Much faster. So this is 2/3 times 1000, right? So this is like 600 something. So did you potential divider between 6,000 something and the 1.5?
6,000?
It's 600. I'm so sorry. This thing.
Oh yeah, I did. This multiplied by 1,000 divided by the total resistance, which is this plus the 1.5K.
Yeah.
Then I multiply by 10.
Yeah, and that is the wrong answer.
Yeah.
Would you please try that in a calculator, just to mention?
So this one, so it's this over this plus 1.5.
Sorry, the video is pausing, so I'm not sure why. Okay. Yeah, it's. There you go. That should be the answer. Wait, times. Wait, what? That doesn't make sense. That doesn't make sense. Just 2/3. Yeah, just 2/3 over 2/3, you know. Oh dear. Right.
Right. So 1 plus.
Right. So you're doing that. Good. Right. Yeah. Is this is not the answer, is what you're saying?
Wait.
Are you sure this is not the answer? Would you please kindly check?
I keep getting this answer. That's 3.1. Oh my, they rounded up. I kept thinking it was 3.08, but the answer was 3.1. So I was getting the correct answer, but I thought it was wrong.
Correct, absolutely. Why is the answer 3.1?
I keep erasing
and doing it. My goodness.
Getting the correct answer the entire time.
Correct. Good news for that. I'll consider that a good news. Okay, never mind the 13 minutes, right? Tell me why 2SF. Just tell me why, because you might not know why it is 2SF. You might not know.
Because this one is all in, how do you say, the simplest, how do you say, the smallest division. Is it?
No, it's not. Between the three numbers, they tell you 4 numbers, right? 10.0, 1.5, 2.0, and 1.0, right? They tell
all of
you
them
4
have
numbers.
1 decimal place.
No. One of them have 3 SF. The other 3 have 2 SF. You notice that? So 10.0 is 3 SF lah. The SF is what matters, not the DP. Yeah, it's the SF.
So you follow the smallest one.
Yeah, you follow the least accurate one, which is 2 SF lah. So 2 SF, not 3 SF. That's the reason.
Yeah.
Okay, so you got A. So how about B? Can you calculate B? B should be.
I try to.
Sure thing. Use the minus one, right?
Yeah.
Very happy that your potential divider is actually correct, because we will need that a lot in the potentiometer. Yeah, yes. Okay, good. Just to confirm, Yanqing, you want to talk about the Jamboard thing, or you want to talk about this math first? Right. Okay. Right.
Yeah, so I need the first page I need with part 4. I solved part 1, 2, 3, I think.
Cool.
Which is here on the camera.
Right.
But I'll start on part 4. So,
sure thing. Just take. Oh, sorry. Could you? Hands are off now, which is great. Okay, good. Okay. Yeah. Nice. C1. Which one? C1. This is C. This is C1, is it? Right.
Oh yeah. That's B part 1. So this is B part 1. This is B part 2. And B part 3. And B part 4. Just ignore this. Ignore the bromine.
Right.
Ignore the BRCC CBR. That's just me like drawing out.
So in part 4, he say from the halogenal propane chosen in C1. We are referring to the B1.
Oh, I think I labeled wrongly.
So 1, 3 bromo. Austin, you're okay, right?
Yeah.
Oh no.
Yeah, sure.
No, like just the question. The question looks like this. So the P is already here.
Oh, that's so weird. Okay, okay, never mind. We're talking about 1,3 bromopropane, right?
Yeah, that's all I picked up.
Yeah. Okay, yeah. Let me check for what. Yeah. Oh, you have already learned amine, yeah. Right? You have no problem with what is amine, lah. Okay, sure thing, no problem.
Yeah, it's a bit like confusing with like the it can keep nucleophile, but you know, this is what it is.
So I'm just checking your answer. You know that KCN basically lengthens the C lah. Basically lah. You know that lah.
Oh yeah.
All right.
Then you
so
you can add like the H2 and then it will
right.
become like a CH, like a
okay.
standard kind of thing, I think.
Right. So that's how you lengthen stuff, right? Lengthen the C lah, right? So in this case, halogenopropane, you start with 3C, right? Start with 3C, and then
and 5.
And you need pentane, which is a 5 lah, right? So you need
I might. Oh
when
no.
Yeah.
I missed out. Did I miss out something?
Yeah, because if you KCN1, so whatever that is the lengthening process, it lengthens by 1C lah. Just want to say, right? Just want to say. Okay. So either you change the starting guy to make it easier, or you change your steps, because I don't think you hit the pentane.
How do I have it? How do I have the C like also like replace this bromine?
Yeah, so the one that I'm very confused right now is really you're supposed to know the KCN reaction. That's like in another chapter. I'm very, very confused with your scope right now. How do you know the C lengthening? Oh, it's here, right?
Yeah, then there's the whole page.
Where did he? What? When did he? Whoa! So in which chapter did he discuss this? In the halogenoalkane chapter, really?
Yeah.
I don't understand your notes. Okay, fine. So you know, So the length of the carbon chain can be strengthened. Now the N is RCN, right? RCN. So what do you do with the CN? What do you do with the CN? Can you do something with the CN? Yeah. That's the question here right now. Can you do? If not, it's Can you do something with the CN first?
I bet like I could do this.
That doesn't lengthen. Yeah, if you do it that way, then it does not lengthen, right? You close the opportunity of lengthening.
But I need an amine on both sides.
Right. So if you need amine on both sides, then the question is maybe the BR can be treated differently, I suppose. I suppose. Right, I suppose that. But you have to probably focus on the lengthening process first. You have a problem there. You can only lengthen to 4. You cannot lengthen to 5. I suppose.
Actually, is this wrong? Like the structure.
Let's check first. So you have to start with the halogenopropane. I don't think there's any other way, but you choose BR. Yeah. Well, first of all, it's 1,3 dibromopropane. Just want to say like the naming thing.
Oh, my bad.
But do you really have to start with 2BR? Just want to check that first. You really have to start with 2BR?
My thought process was that if like the CN can like substitute both sides of the BR, like here, sorry. The CN can substitute both sides of the BR.
Then
I can add the H, like get a H and I
both.
Get like
good.
amine on both sides.
Good, I like it. So you solve the problem. You lengthen at both sides. Correct what? That's why I'm confused. How come you don't immediately say that, I suppose.
Yeah, I think here is wrong.
Because at least you must draw CN at both sides first. At least you must draw that, right? So CN at both sides, and then you just aminify or whatever you call that process, right? So then done. Okay, you clear that first. So for Austin, obviously the new V is definitely correct. So any problem with C with 7 so far?
Not yet.
Okay.
I'm ahead of my tutorial, so I honestly don't really. I'm just finishing up my tutorial so that next time I don't have any work to do for this one.
I like that you're ahead. I really like you're ahead of everything. Math, chem, physics.
For chem, my teacher, she has like no mercy, so just give all the work. But then
So right.
for
Okay.
physics, my teacher doesn't really specify what to do, so I just finish it.
Which is very nice. I like your attitude. Then math.
Then for math, I finished also already. I can't like stay back at school and just do.
I like your new working habit. I like it. Very good. Are you tired?
Quite though.
Let's talk about rest later. But you know, I'm very happy. Go ahead.
But I mean, once I reach home, I have lesson work to do, so it's fine.
Which I really like it. I think your mother might like it also, right? Your mother might like it also.
Yeah.
Less tension. So Yankin, yeah. So you know that you have a double CN at both sides, though. Then they just, you just continue with the double CN, right?
And at the CH2 and H2.
That thing which is you can just see from the note done, right? So yeah, so done. So far, maybe you'll miss some details, but
then like part 4,
right? So from the same halogenopropane, which is a 1,3-dibromopropane, which is great, right? Propose a 2-step synthetic rule to propose bromoethanoic acid. So only one of the so it seems that only one of the bromone changes. Wait, let me think for one. Dibromopropane to bromoethanoic acid.
Yeah, because like when I was looking up what the bromoethanoic acid is, because I didn't know, I thought like it was a structure like this. And then O and then like OH. So it's like missing one C, and I don't know how to.
Yeah, technically there is no. Technically, there is only one reaction that shortens the chain. It's called cracking. You would have learned cracking from alkane to alkene, either one, right? Technically, there is only that, and yeah, technically there's only that, right? Technically. Oh dear. Technically, there is only that. Okay.
I think yeah. Crude oil and cracking process.
I mean, the questions are very, very good in terms of exam level. It is good. This is what you need to practice. That's true. You check out the cracking for a while. So you just see the example of a cracking. Yeah, there, for example. So there is no, it's a random, cracking is random, right? Cracking is random. You can crack to 2, can crack to 3. You cannot control where the cracking process will happen. Clear? In our case, however, there are only 2 spots to crack, between C1, C2, or between C2, C3, right? That's the only place to crack. So if we are doing a cracking, one of them will produce 2C, one of them will produce 1C, as simple as that.
Yeah.
Right. So that's one option, because if we are not reading the question wrongly, if we read it correctly, technically there is only one way to shorten the C length.
Yeah, I wouldn't have thought cracking.
Right. I don't think there is any other way. I might be wrong. I might be forgetting 1 or 2 things, but I don't think there is.
Tomorrow, I guess.
Right. So you do that first, and then you complete the carboxylic acidifying thingy of the other end, and then we'll move on. Right. Austin, okay so far?
Once I finish this question, I have a question for maths.
Good. Let me confirm that you actually have not reached potentiometer. Potentiometer is not potential divider. It's not.
Oh yeah, I finished already. As in I finished the the lecture already.
Oh, but you haven't done the tutorial.
Oh, I haven't done the tutorial yet.
No problem.
Still, I just watched it yesterday.
No problem. Still okay. However, if we have extra energy or time, we devote on potentiometer to make sure you understand.
Okay.
Right? But at first it's fine. Yankin, you okay? Oh no, you're just checking. Sure.
They said I need to check state the reagents and conditions. So
cracking. Yeah.
Let me see.
Yes.
For this question, right, when they say that the balance length was 0.050 meters, right? Does it mean is this from here
Is
here
this
to
a
here?
potentiometer? Oh.
Yeah, potentiometer. From here to here is 0.050, right?
We don't know. Let me
say
see.
the balance length.
Let me see, because it's either that short one or the long one. Let me just make sure.
The long one is 1.2 meters.
No, as in the right hand side, the right hand side of the. Yes, it is. The balance length is 0. As in the first thing that you point, that is what they call the balance length. Yes.
So it's this one, right? The short
one.
That's correct. Okay.
That's correct. Yan can tell me when you're ready to move on to the next.
Yeah.
Are you ahead of class?
Me?
Yankin, yes.
Yeah, I'm pretty sure. This is for tomorrow, and I'm mostly done with it.
I'm very happy. So you're ahead in terms of tutorial.
Yeah, I'm like slightly ahead in terms of lecture, but like
good,
not by much.
You just have to be ahead the day before. Right.
Yeah.
There is absolutely no need to be ahead 1 week ahead. Please lah. No need. Please no need. Until your university, you don't need to do that. Have you been more active in the lecture, as in you start to do questions, a bit challenging yourself?
Sometimes when...
Good. Sometimes.
Okay, I go toilet for a bit.
Yes, please. You have been trying this, this slightly new approach to studying, to working, we'll just call it, for what, 2 weeks already?
Yeah, about 2 weeks.
Right. How do you feel?
I'm tired, more tired than I was last year, but it feels good.
You're more tired? You're saying more tired?
Like last year, it was like the bad kind of tired, where it's like I tired, but I know I'm not doing anything. But tired. But now it feels like I'm tired as a result of like actually trying to do something,
I like.
So it feels better.
Definitely. That's what we should normally feel, right? Feels good. Have you been resting on Friday night, Saturday, and Sunday until lunch?
Oh, I think I rest Saturdays. For like Sunday I get up there start to work.
Friday night?
A bit, but I usually just go sleep.
Yeah, please don't do anything on Friday night. Please don't. Right? And then Saturday you don't do anything also in terms of being productive. Please don't. As for Sunday, it's up to you, but feel free to start after lunch. Feel free.
Yeah, I don't think I'll be comfortable with that. I think I'll just like start when I wake up.
Yeah. Please rest, Please rest. It's not quantity, quality. Even during exam, you should be doing that. Actually,
I don't know.
Especially during exam, you should be doing that. This has to be very clear. Especially during exam. If not, you die. Then you're... Okay, good. Okay.
I think I got it. I'm not sure if like this is allowed, like substitute with CN followed by acid catalyzed hydrolysis. I don't know. Is it allowed?
Yeah, but the problem is if you do that, the C becomes 3 again.
Oh yeah.
As in, are you taking? That means you are taking the shorter cracking result basically .
Yeah, I guess I could.
I suppose you have to specify that, and let's see whether that's correct. Let's see tomorrow, right? Yeah, just specify that. You do have that option. I suppose that is an okay way of it. Yeah, I suppose. Yeah, that's good.
Let me just three. Wait, let me think. Wait a minute.
Yeah.
Let me because bromoethanol acid has like a bromine attached to it. So but I'm substituting the bromine with CN.
Oh, yeah. So let's draw the result of the cracking first. Just draw them. We can draw them there. Just draw both. Let's say you have two results. Let's say you have two results.
Then it will be
yeah, the first one will probably be wrong. I think the first one will probably be wrong. You have to think about it. Yeah, just draw the second one. Just draw the second one. The second one probably cannot be wrong. You have to understand cracking. Yeah. Okay. Yeah. Okay. Okay. Yeah.
Maybe, I'm not sure.
Yeah, let's take that for now. Let's draw the other one.
I don't know how this could be any different, but
yeah.
I'm not sure. I mean, cracking was like
I think
like
this is a little bit difficult. But let's say, just for our level, let's just say that we're going to use the. Okay, you think about it. Are you going to use the second one or the first one? Because you know what? Now you realize
that bromine has to stay, right?
That means you cannot use your step 2. You cannot use the CN one. There are other options like the one you strong oxidation. Yeah, strong oxidation. Usually they talk about it's a strong oxidation in the 18 chapter.
Me alkene.
Alkene, sorry. Yeah. So let's see whether that works or not. Because if it doesn't work, then we have some problem. They usually describe it as one page. If you want to look at the summary, that's fine.
Wait, I think that might have been. Give me a second. I can't remember there was a COH reaction for my alkene, but I forgot what it was.
Yeah, the one that you are trying to the strong oxidation when you are trying to attack the double bond line in this case lah.
Yeah, but doesn't that break the double bond?
Yeah, which is a big problem again. Which is again a very big problem.
It breaks because I need 2 carbons, right? That's what bromoethanol acid is.
So now you realize then technically there is another reaction which cuts the C, the strong oxidation of the double bond. That does shorten the main C backbone also lah. Correct.
So
technically,
I form. Sorry, you're saying.
So technically, if only the starting guy has a double bond, you can also perform this lah. Technically lah. But obviously, the starting guy does not have a double bond, right?
What if I did like elimination of.
H2?
If I eliminate this, eliminate the original one.
Yeah.
Then I take out Br and H and form a double bond here.
Yeah. No, don't take out the Br and H. No. If you can, take out 2 H's. If you can. Well, I mean, if you cannot, then you take out the HBr. Yeah, fine. Yes.
Yeah, but I only need 1 PR, right? So
correct. So I suppose you can do that. Yes, you can do that. So yeah. So now you will know 2 ways lah of shortening stuff lah. Now you know 2 ways.
I need space then.
Or you can use a post-it to create additional space. Do you have post-it? Didn't I send you a big post-it? Didn't I?
Yeah, it's somewhere here.
If you can find it, that's the best way to add space, if you can. If not, then, well, you do something else. Austin, are you okay?
Yeah, I finished already.
Good. So the potentiometer, at least for that simple one, you are happy lah. You're happy.
Yeah,
right?
I got the answer already.
Sure thing. So can give me math if you want.
Wait, I'm looking for my maps.
Yep.
Yeah, wait, do you want me to go through the potentiometer first, or do you want me to ask my...
Math first.
Oh, math first.
Your honest real question first, that will be.
Yeah, I leave the Maclaurin for next time.
Because
I haven't started the tutorial yet. My teacher's
sure.
going through. So it's
Understood.
hard. I really don't understand Maclaurin. It's very confusing.
Let's go through that. Yeah, whenever we have the chance, let's go through that. I want you to understand. It's not difficult.
I find it so difficult.
This is our opportunity to make it easy. It's not. Yeah. So that's the.
Oh wait, no, it's not Maclaurin. Sorry. I meant permutation and combination.
That's confusing lah. That is.
Yeah. That's the how. Not
that is
Maclaurin.
confusing.
Sorry, Roman.
Maclaurin is not confusing in general.
Okay.
That's the post-it I give you. Really.
Oh, I thought in half last time because I need to use half of it.
Okay, sure.
So this is the other half.
Yeah.
Sure.
Applications
of integration.
Sure. Are we at volume of rotation? Volume of revolution, sorry.
So yes.
Oh, that's
I need help with
definitely where
5B.
5. Let me take a picture. 5. Yeah, okay, the picture. That 5B looking good. So what's the problem? Sorry, wrong. Right. What's the problem, Austin?
I really can't do it. I tried over here. This is my initial
5. Okay, let me just take a picture of that. Okay, let's talk about 5. Let me understand what's your problem. You mean you can do 5A, right?
Yeah, I can do 5A.
So rotated through pi radians simply means you just have half the volume. Just want to check that, okay?
Yeah, I'm adjusting the yeah.
Yeah, so rotated to pi, no problem, right? That means it's a half volume, right?
It's half of the volume, yeah.
That's not a problem. Now, figure B, let me okay. So this is x squared plus y squared equals to 12, and this is y equals to x squared, correct? Right, you found the... Yeah, you can just call that root 12 lah. That will make things easier, right? Instead of this ugly number, you can call it 12. Yeah, okay, great. So obviously they ask you in y, I think because that's the easier way lah, compared to x, right? I suppose. So all you have, that's, I don't know why this is very difficult. Okay, so let me check what you did. Did you, for example, oh my goodness. It's rotated like this, right? You know that, right? It's rotated like that. So you need this limit or you need this limit?
Oh yeah, that's why I use that limit.
Which
vertical
one?
No, the other one.
This one.
Yeah.
All right. Then let me ask you, what is this? Because I don't see you go and find this. What is this one? I don't see you do that. I don't see it in your...
It's 3.
I'm just going to do something, right? I'm going to find that point, right? I'm going to find that point. So I notice this and that is the intersection, right?
The border is 3. I wrote 3 over there. It's the same height, right?
Can I just make sure? Just a minute. Can I just make sure? So this is x squared plus x squared, right? Minus 12 equals to 0, right? The easiest way to do it is actually y. I think it's easier. Y squared plus y minus 12 equals to 0, right?
Yeah.
I'm just confirm this is y minus 0. I'm assuming that you can do that. So plus 4 minus 3, right? right? So y equals to -4 or 3 lah. So I suppose it's correct lah. I suppose, yeah. I suppose. So it is 3. So my question is, the volume revolution you do at wait.
As in, I cannot visualize which volumes I should find. Like as in the shape of the volume. So what to minus off and what to find. How to explain that? It's like, because like
yeah.
the way to solve is like a volume of, for example, this minus something like this, then I get the shaded area.
Correct.
The volume of the yeah, but I don't know what minus what. I cannot visualize it.
Fair enough, right? So the concept is like this. The concept is a volume of revolution, right? So the volume of revolution is either like that or like that, right? Now I'm drawing this as this is the y-axis and I'm drawing this as this is the x-axis. Notice that I didn't draw this part. I also didn't draw that part. Notice that. Huh? So the rotation would be like that. And so this small sliver will form a small disk. The sliver becomes a disk. This sliver becomes this disk, right? So in this situation, you must draw the sliver. If you can draw the sliver properly, you can do anything. Now, I want you to draw the sliver.
I can't.
Right. So again, let me ask you, very simple, right? This sliver, I won't rotate like this, at least in this case. This sliver, I will just naturally rotate this way. In this kind of question, that should be enough. So I'm going to rotate like this, and this sliver, I'm going to rotate like that, right? I will not entertain the idea that this sliver I can rotate like this, because I can, but I won't entertain that. Okay, yeah. Huh? So, never mind. What I said, never mind. Okay, what I said, never mind. Again, never mind. So, if I'm going to rotate like that, which sliver do I choose? This sliver or that sliver? This sliver or that sliver? If I'm going to rotate like that, you see?
Or the top one.
Correct. So please draw that sliver in your paper lah. Just draw that sliver in your paper.
What do I draw?
Like draw this shape properly in your figure B. Please do that.
Oh,
no, inside the shaded area. Yankin, are you waiting for me? Please don't.
Oh, yeah, I have a question.
Okay. What is it? If a short one, I can answer.
Yeah. Okay. So I was doing the oxidative cleavage, right? So
yeah.
Will this H here and this H here turn into OH like this one?
Will what? Sorry.
Will the H's here and here turn into OH like this one?
You mean in the strong oxidation?
Yeah.
I think it only attacks the double bond, if that answers your question.
And the H associated with the double bond?
Yeah. So the single bond H's does not suffer much. Okay. Okay. So no, Austin, I'm looking for this instead. Look at. I'm looking for this kind of sliver to make the concept clear. I'm looking for that. That is the sliver I'm looking for. That's the concept you need to have in mind. That sliver. So you draw that sliver.
Sure.
Anywhere, but yeah, roughly there. Right? Now notice that this sliver is really a sliver, and is it dx or dy?
Dy.
Correct. So this is your dy. That's your dy. Just to be clear, therefore this is your dx. So it tells me that your dy here is a good idea. It's a good idea. So first thing first. So there is a dy. So it tells you that you have to have y dy. Secondly, the limit is therefore, I was trying to test you lah. Is the limit therefore this to that or this to that? Which one?
The horizontal line that you drew.
No. Sorry, yes, the horizontal line. I'm so sorry. Yes, the horizontal. This one and this one, right?
Yeah.
So last thing, did you notice that you are supposed to have 3 limits from here to here, and then from here to there separately? Did you notice that? Did you notice? I think that's the easiest way to do it.
Is it to find out this volume here so you can minus off?
No, I do it in a very simple way. So now I'm no longer doing sliver. I'm just doing that using obviously this guy, right? And then I do separately this guy using that guy, no, with the appropriate limits. I think that's the easiest way so far, if that makes sense to you.
Oh, so you divide it into different parts.
Because and using different curve, which I think is very natural, I think.
Yeah.
Right. Okay. And you still use the y equals to 3, right? So from 0 to 3 using this guy, and then from 3 to root 12 using that guy. And then you just apply the normal formula. Okay?
Wait, 0 to 3 using y equals x squared, right?
Yes, looking
then
at
3 to square root 12 using x squared plus y squared equals 12.
Yeah, if that makes sense.
Okay, let me try again.
Give it a try. Yeah. Yes, Yankin, what's your question?
Yeah, I think it's fine. I think I got it.
Good. So let's wait for tomorrow. We don't have to fast too much, right?
Okay. I think we can move on to the second question.
Sure. You mean the second question? Okay. So right. Oh, you have the answer. Yeah. So
yeah. I think they read first.
Right. So ethyl benzene. Yeah. So you have talked about arene. Yeah. Wow. This tutorial mixes everything. Like this tutorial just mix every chapter there isn't.
Yeah, I guess it does.
Wow, he's treating you like advanced student, which, well, it seems that therefore you are. Very good. I don't mind. I mean, I feel it's a bit too fast, but I don't mind looking at how you deal with it. I like it. Okay, fine. So, okay, yeah. Oh, yeah, sure thing. But with aqueous, yeah, sure, okay, no problem. You have learned ketone, really?
I mean, it's like a passing mention, but it's all on my chart, and I'm supposed to remember it. So,
wow, you have learned so many. Fine, no problem. B is inert towards aqueous sodium hydroxide. Yeah, fine. Okay, right. So,
I think I've gotten A. I think I've gotten like A and C because like they're related, right? Okay, so I think I got it.
Right.
But I'm having trouble with B because let's see what I trouble with it. I trouble with it because it was oxidized by because it was oxidized by that, it becomes C7H5CO2. I think it was.
Sorry, wait. This ethyl benzene treated with chlorine. Let me just confirm this. In your arene chapter, if I'm not mistaken, back then you did not reach a point where the benzene ring is being activated, like kind of activating or deactivating thing.
I believe they had that, but like I didn't. I wasn't the best at maybe.
Are you saying that in this situation, therefore, you don't consider activating, deactivating, but you're actually considering free radical substitution? Is that what you're saying?
Yes.
So you're basically not considering the benzene ring at all, basically not.
I don't think so, because there's a C2H5 there.
So the question is, the C2H5 is not activating, is basically what you're saying.
Probably not.
But look at what you're showing me, methyl benzene. C2H5 is, well, it's not methyl benzene. It's similar to methyl benzene. Hence the methyl. Whoa! You're there. You're at the right place. You're at the right place. Read the proper page. Yeah. See, methyl benzene. I know you're not methyl benzene. You're ethyl benzene, right? You're ethyl benzene. But hence the methyl or alkyl. Alkyl is a general term for methyl and all its other brothers, including ethyl, right?
Yeah.
The methyl or alkyl group activates the benzene ring. Activation means it will lend itself to further reaction, right?
All right.
So just want to confirm that this activating situation you are not considering at all.
I did not consider it when I was
But you also did not. Okay, so let's see. Look, so how does this activation thingy, directs to the 2 and 4? You should have a summary table at behind, like if it's activating, then what kind of reaction is possible, right? That kind of thing. Because it's not nitration now. We're not talking about nitration here. We're talking about something else. That's not the summary table. Usually there's a no. See something slightly different then.
Let me check.
Yeah. This thing. See, the alkyl is activation, right? Then you sub to 2 and 4. The question is, what reactions are possible once you activate? That's the question. What reactions are possible once you activate, which is basically you are activating it with the alkyl. You're already activating. Is there any reaction that lends itself to, chlorination, I suppose? Chlorination.
Any reaction?
Yeah. Can you chlorinate the activated benzene ring? Can you? Is there any reaction?
Yeah, pretty sure I can.
And again, please show the reaction if you can chlorinate. It's somewhere here. Somewhere here. It must be somewhere here. Halogen? No. This is talking about already having halogen and therefore it's deactivating. We are not talking about that. We're talking about if it is activated, what can we do with it? It's not just nitration. No, free radical substitution is just sitting. Yeah. When oxidation. No. Your note is a bit weird. Okay, let's talk about this. Let's look at the summary. Yeah. No, the summary. So let's go one by one. So the reaction of hydrocarbon and methylbenzene. So methylbenzene is an activated benzene, right?
Yeah.
You can react with Br2 with a free radical substitution, which is or electrophilic substitution. Reaction of the benzene ring on the benzene ring.
Reaction on the side chain or reaction on the...
Yeah, you see? So you'll probably get one FRS, maybe that's what he's aiming, and you probably want to get one electrophilic substitution. Perhaps, I'm guessing.
Okay, so I guess B will be the electrophilic substitution.
Yeah, which therefore the Cl will be on the ring.
And that's why it's enough to sodium hydroxide.
Because once you Cl, you deactivate and everything, right? Once lah.
Okay.
So you're solving some. Yeah.
I still need to prove that it can form the acid B, but give a second, figure this out first.
B is inert, but it's oxidized. I am guessing that it is just a strong oxidation of the. I think it's just a strong oxidation of the side chain. I'm guessing. Okay, because there's still the side chain intact, right? The one inert is the benzene ring, not the side chain, right? That's possible. Are you okay? Are you okay?
Huh?
Are you okay?
Yeah.
Hey, how come it's very long?
Huh?
Never mind. You're right. I'm just following.
Oh, I'm just what do you say?
Okay, that's not
overlining with pen. Can erase the pen? So
yeah, that's nice. Yeah, I like that. Okay. Why did you why did you do the integration twice? Huh? What?
It's okay, just a more detailed step. I got the answer.
Okay. Did we settle your confusion? It's a visual confusion.
Yeah, it's a visual confusion.
Yeah, and it's very nice if you can settle it. It's very nice. Eh? It's very nice. It will be useful.
Oxidized by
the side chain. Probably the side chain. I'm guessing it's a side chain, right?
Let me check then.
There is
How would it?
So
this is C6.
Austin, I think your handphone is acting up again. So, he's doing all the up. Yeah, it's back. That's the Apple phone. That's Apple.
But how did it go from, how did the sidechain, because the asset is C7H5, right? So,
okay.
Assuming that six of them belong to the benzene, which benzene don't touch, right? That means the sidechain now has...
No, not 6. No. The benzene ring does not have 6 originally because one of them is already replaced by Cl. Hello, at least one. You are forgetting. You're forgetting the other guy somewhere. The ethyl is also replacing the H also. What? So you have the side chain. Yeah, basically you have 2 side chains, in B, right? You have
and
the origin. No. Look at Jamwood.
Yeah.
This is already not C6H6. This is already not. Why? Because it's C6H5. One of the H is being replaced by the ethyl. Right? When it becomes B, the one more H is being replaced by Cl. One more. So it's already now C6H4, C2H5, Cl, right?
When you are talking about A, right?
B. I'm talking about B. B.
B. Oh, it will be C6H4.
Yeah, right? C2H5, Cl, right? Right? So inside here, you have, C6H4, the original. Then, you work out from there.
But then, okay, so it's C6, so it'll be...
Oh my goodness, so write it down. So I prefer that you draw, but, then you have this, and then, then you have oh my goodness, Cl and C2H5, right? Like that, right? I'll just do it like that, right? Okay. Basically, this is B, right? Something like that. Then your D is basically C6H4 still, right? There's still the Cl, right? It's untouched because it's deactivating. And then you have your COOH. Got that? Right?
But what happened to the other carbon in the side chain, the alkyl side chain?
You think about how, if it is possible, because this is a guess, right? The guess is this is untouched. This is untouched. That's my guess. Let's call it my guess. So is there any reaction that, oxidizes the side chain into that? Is it possible to do that? I'm giving you so many hints already.
Let me try.
Yeah, check it out. It's the terminal C thingy lah. If it is possible to do that, then we have a possibility. Right. Yes, Austin. Sorry, you have a question.
Yeah.
Which question?
7. Yeah. Oh, yeah. 7 part 2. I can't find this one.
A bit to zoom in, zoom out a bit.
Oh.
Zoom out a bit. Because I cannot read the question. Nice.
I can't show that the area under the curve is to integrate. I can't show this part. But I solved this one, but I can't solve this. I solved the subset. I can't show that it's this.
Right. Okay, so let's see.
My working is where I say call my own. Here, this is my working.
So let's see. Yeah. So you should be doing dy dx with the help of dx dt and dy dt. That's the first thing I will try also, right?
I tried to do that, and then I wanted to integrate this to get y is equal to something. So I find the y, the length, the formula of the curve by
you have to integrate
this.
You have to integrate 2 times, not just once. If that's your original goal. Because you do not integrate the dy dx. Of course, when you integrate dy dx, you get y, right? You get y as a function of x. But you're supposed to find the area under the curve y. So integration of y. Not just integration of dy dx. You have to integrate twice.
Oh, but I'm just supposed to find the formula of this one. Because this is a y.
Oh, you're correct. No, you're correct. I'm so sorry. You're correct.
Yeah, but then when I integrate this, right, I don't get this.
Something simple, right? Something simple. Understand? Just a minute. Yankin?
The only way I can see it is eliminate, then after that, eliminate, then form a double bond in between the C, and then after that.
If you can do that, no? If
yeah,
you
but
can.
The question says it's just oxidized by aqueous potassium manganate to acid D. Which
is again a very strong oxidation, very strong oxidator.
Yeah, but how that form the alkene? How they form the double bond? Sorry.
It does not. It does not.
Okay. I'm missing something.
Okay, I'm going to answer Austin's question. So you think about it, or you can do another question. So don't wait for me too long. Right. I'm checking your working, Austin. Yeah. Yeah. Okay. Yeah. Yeah. Okay. Well, I must admit that's very disturbing. I think. And furthermore, you cannot do that. Yeah.
Is my method correct?
Oh my goodness. I just realized something. Let's just say that this is all correct. I'm just checking very quickly one more time. Yeah. So let's say I didn't miss anything also, and let's say this is correct. The problem is this. Now you need this guy, right? And this guy is supposed to be y lah, right? As a function of x, which is it's not. This is in function of t. So the best I can say that maybe this is y as a function of t, maybe.
Oh yeah, but then if I integrate this, will be in function of t also.
Yeah. So the problem, first of all, that you don't have a dt. It's a big problem. You need to have dt. You cannot integrate this. Okay. So one more time, let me state this very carefully. You have to understand, you cannot integrate this because the variable is not ready. The problem is the variable. You need dt to integrate to t. You need. So for example, you need, so I'm going to put dx here. Again, you see the problem. You need to change this. One way to handle it is to change this to whatever dt lah, something lah, because you probably can do that. At least you can probably do that. In fact, you definitely can do that. Look at that. You already have it. Look at this. So dx is equal to 2 cosine theta minus sine theta dt, right? Which you just replace that. Do you understand? You have to do that. You have to. That might be the ticket to your problem, to your solution. Do you understand? We are a bit cut off just now. A bit cut off.
Yeah.
Okay. Do you understand? Would you like to try that, Austin?
Yeah.
That'll be the problem. Yankin, yeah, you're still thinking about the thing. Yeah. Okay, let's see.
I don't see how we could. I don't see how aqueous potassium manganate would be able to not only will be able to break off this bond.
All right. Let me think. You cannot strongly oxidize. You cannot strongly oxidize a side chain, even though it is an alkane side chain. Because alkene is just like that one. Alkene is very resistant to changes.
Yeah.
The only thing you can do is burn it, which we're not going to get. Let me think for a while. Either B is wrong, or but I don't think that B is wrong. I don't think so. I think D is correct. And treating it with chlorine will not change the nature of the, will it change the nature of the halogenoalkene? Well,
Sorry?
it did in the free radical substitution. In the free radical, it changed the nature of the ethyl into a
chlorine, like while the H came out, the chlorine went to the outer section.
And we are very certain that A is the halogenoalkane. We're very certain, right?
Yeah, I'm pretty sure. Like a lot of it.
Yeah, because halogenoalkane can react with so many things. Halogenoalkane is very interesting that way, or annoying, whatever. But currently I don't have an answer yet. Currently I don't have. Yeah. So either you'll find out tomorrow, or I think about something before tomorrow. Right? Sorry about that.
Yeah, I guess I could just do part B.
Yeah. I mean, the way we prepare for everything. I mean, the way we prepare for tutorial is not that we can do everything. It's not. Right? Austin, are you okay? Austin?
I'm very, very confused.
Okay, first thing first. Do you understand the need to change dx into dt? Do you understand?
Yeah, because if not, I can't integrate it.
Correct. So you start from the dy, the dx dt. The dx dt is as you have written. You need to.
Then, but so does that mean I just integrate this?
No. Stop integrating stuff. Stop. The dx dt part, just write down dx equals to that whole thing dt on the right hand side. You're just moving the dt to the right hand side. Write it down first. Yeah, this is the. Believe me when I say dx over dt is really dx over dt. It's a division. So you can
my
simply.
teacher said we are not allowed to write it down.
But it is really like this, It is really like that.
Yeah.
So with this in concept, you can now change the dx of the bottom guy, which first of all, again, you move the dx to the right hand side first. And then you change the dx into this. Even though you're not supposed to write this, problem solved. So the dy over dx, right, which is like your minus 3 over 2 sine t, you move the dx into the right hand side, please. Move the dx into the right hand side. And then change the dx into the guy on top. Then you can integrate. Okay, now can you integrate this and will it get what you need? That will be the question. I don't think so. That's the problem. Is that power 4 or power 3? Is the question power 4 or power? It's power 4.
4.
Oh, that bothers me.
I guess sine square t, not.
Okay, let's try first. Anyway, let's try first. Hey, don't write dy over dt. Oh, well, you can. Yes, you can write it. I'm so sorry. You can write it. Yes, you can.
Yeah, I got this.
Oh, yeah.
Yeah.
Oh, it's sine. Why is it sine cube? Why is it sine cube? Why is it not sine square? It's sine square, right? It is sine square, right? Yeah. If you want to write dt, the dy shouldn't be. I can get sine cube lah. I can get sine cube. It's a bit weird.
I can get sine cube. 4.
Yeah, I cannot get sine to the power 4, but I can get sine cube. So let me just check whether there's any problem. So x is cosine square t, y is sine cube t. Okay, let me no. Okay, may I ask something, Austin? May I ask something? This 0.5 pi, right?
Yeah.
0.5 pi, and then this should be in terms of t, right? What is this again? Okay, because I cannot read properly. What is this?
0.
And then
the top one is half pi, pi over 2. So it's the entire graph here.
So the question is, this is area under the curve with respect to x-axis or y-axis? I'm very confused right now.
Yeah, I'm also very confused about that.
Maybe that's the solution. Maybe that's the solution. Can you plot this graph? Can you plot this graph?
Oh yeah, it's this one.
Oh, very nice. So then, how shall we find out? You know, never mind, never mind. You leave this thing for a while, because we know we don't get it. Don't erase it. Just pretend now, instead of integrating this guy, you're not going to integrate xt, which is to say, you're not going to change the dy into, you're not going to change the dy into the, no, it doesn't solve the problems. No, it doesn't solve the problems. No, it doesn't solve. Does it? Wait. Unfortunately, it doesn't. What's going on here? Maybe something is wrong in the working, maybe.
But I double checked yesterday. This one is definitely correct.
It seems correct. Okay, sorry, I'm blurred. I'm very blurred here. So let me confirm, this is x equals to cosine square t. This is y equals to sine cube t, right?
Yeah.
It is, right? Okay. Yes, correct. Because sine 90 is 0. Yeah, I totally agree. This should be y. This should be integrating y dt.
When my teacher will go through this.
True. Let's leave it for now. Maybe
another question.
All right, sure. Let's talk about that.
Yeah. Last question. Question 11.
Looking good. Shaded bar, whatever your exact area of the region. So let me just take a picture of that. Okay, is your question A or is your question 1 or 2?
Both.
One is you just approach it as a circle.
Oh wait, no, wait, I got one.
Yeah. You should just approach it as a circle. Nothing complicated.
That's here.
When region R, the shape is rotated through about the y-axis. Yeah. So this is a slightly more.
It's a very complicated shape to imagine.
Yeah. The problem is the visual side of things, right? Totally agree. Oh, you haven't done anything. Sorry, no problem. Right. So now again, same thing. The sliver is what's helping you. The rotation is like this, right? Correct.
Yeah.
Draw the sliver. The sliver is what matters.
But I don't know where to draw it.
Hello, if the
here.
rotation is like this, then what should the sliver look like?
Oh, like this.
Draw the sliver, right? That's the important thing. Yankin, are you waiting for me? Sorry.
Yeah, there's a physics question.
Correct. Okay. So draw the sliver first.
Unless like, like the top.
Yeah, but the sliver should be on the R area, right? Should be, right? So I'm gonna draw that.
But I can't see if I draw it there.
No problem. So I'm just gonna just let me. So like that, right? Like that. So again, the limit is, how does the limit look like? It should be here, right? This is one of the limit, right? One of the limit, right? So you need that guy, right?
Yeah.
This is another limit. I will argue. You also need that guy, correct? This guy, however, should probably be approached differently. So I feel you need 3 limits. I feel.
This one must be done through the. This one is, how do you say it? It's like, so I find this limit. So I
cannot see your working.
Oh, my bad. So I find here
Yeah, you need that. You
here.
need that. Yeah, you need that.
Here.
You probably need that, and you also need
here.
That one is not important. No, that one is not important at all. That one is. I don't think this thing is important. You can give it a try. I don't think it's important at all. I think this part is just this minus that, correct or not? This minus that law through this limit law, right? Correct? Correct or not? Does it make sense, Austin? Are we cut off? Are we lagging?
I'm thinking.
Right. Okay, so go ahead. You think?
Wait, so
yeah.
Oh.
Right. You think about it for a while. Handle this part first. This part is probably the easier part, maybe usually. So Yan Kim, yes. So that's the physics question, right?
Yeah.
Nice
I want you to tell me what you think the answer is. The answer already, but my teacher explained it very odd way.
Yeah. Outside the region. Oh yeah, sure thing. Okay, fine. Yeah, good. Okay, so the stiff wire is static. Let me see. Oh, then there's a current. Okay, good. Yeah, okay, great. So what's your question? Sorry.
What do you think the answer is? Because my teacher went through this today, and honestly,
this is ABCD, right? This is ABCD.
Yeah,
right?
ABCD.
So I am how to say this? I am not doing the proper way. I'm seeing whether I can shortcut things first, right? So I'm looking at it from this point of view, right? So the direction of the wire, the current matters a lot from X to Y. Okay, right? So there, right? And since from X to Y, I'm looking at it from this point of view, so it should be going into lah. If it's going into, that's like that, right? Okay, that's the current. Yeah. So this is 2.6 here, which is if I use the right-hand rule, I will obtain I'll obtain a B, which is like that, right? That's my B lah, caused by the XY thing, right? So far so good. Then the NS here, this is the N and this is the S. I'm using a different color, so I will now get this.
The NS is the one I wrote.
Oh,
I wrote the NS.
Oh, polarity of P. Yeah, no problem. So we'll assume that is NS. No, doesn't matter. Don't worry. We'll assume that is NS. Assume. No problem. We have to start with an assumption. No problem. Because it's only NS or SN. Doesn't matter, right? Okay. So now we know that this should cause the force. It should cause the force, the resultant force, to go down. Because the reading on the top end balance increased. So the resultant force should be downward lah. So we'll just have to check whether that's true or not. Am I okay with it?
Okay.
Right? Am I okay with it? Right? So what I'm using is Fleming left-hand rule or Fleming right-hand rule?
I didn't know right-hand.
All right, so left-hand rule. So easy peasy, right? So I'm going to draw my left-hand rule, right? My left-hand rule is, does your teacher mention like FBI or F father, mother, child?
Yeah, the force and after
right, fine. Right.
And the magnetic plus density.
So I'm using my left-hand rule right now here. So I'm gonna yeah. So according to my Fleming left-hand rule, the current should be like that. That's I. The B of the NS law, not the B of the I, but the B of the NS should be like that. And therefore I will have this F. So it seems that according to my left-hand rule, I like that this is N to S. I like it a lot. FBI. So it looks to me that the polarity of P is now confirmed to be N. First thing first. So far so good. Because of Fleming left-hand rule.
P, where is P? P is the right side one.
Oh, I'm sorry. Right. P should be south. I'm sorry. P should be south. Sorry. I thought P is this one. So this is wrong and this is wrong. Okay. So far so good.
Okay.
Then whether this or this is correct, we just have to use the proper formula. So what are you doing? Proper formula?
I do calculation. I did the calculation already. It's 0.197.
Okay, then the answer is C. Sorry, D is
it? The 0.197. So the answer is C. That's what I wrote.
Then,
but the teacher said the answer was A.
Which is to say it's the same 0.197, but it's now north. Let me just check.
Yeah.
Yeah. Okay. So how did the teacher explain?
So
wait.
I don't think I see it there.
Wait, let me think for a while. I'm sorry. Wait.
Okay.
Oh my bloody goodness. Your teacher is correct. I'm so sorry. So the explanation is this. The force is on the wire, right? That's the force. Action, reaction. So this is force on what? Force on wire, right? On wire by who? By who?
By magnet.
Yeah, by magnet. The one that is, oh my goodness, your teacher is correct. The one that is causing the top hand balance to, increase the reading is not this guy, because this guy is not being weighed by the balance. It's not. The balance is weighing the magnet, right? Okay. So the magnet is being lifted. The magnet is being lifted. F on magnet by wire. So in this case, there will be lessening. Your teacher is correct.
So the Fleming's left hand rule, that force is upwards.
Yeah, it should be upwards so that the reaction force on the magnet would be downward. Very good question. Very, very good question.
Is it? Why have this misconception? Because sometimes it will be on. Sometimes it will be on, like this side will be on the magnet. If that were the case, then
I'm not sure what you're pointing. I'm not sure what you're pointing. I cannot see what you're pointing.
Oh,
I see your page, but I cannot see what you're pointing. Like it's cut off.
Oh, I was doing on the Jamboard, but okay.
Right. Sorry, I'm not seeing anything. Sorry, I'm not seeing anything. Yeah.
Yeah,
sorry,
I put it away. So I was wondering why I had this misconception. Is it because imagine the north-south isn't there? Like if the magnet was, if this side was on the weight, right? Would that make any difference?
If which side? Which side? Which side is on the which side?
Like this side.
Like seriously, pointing on the paper is much faster, right? The is like if this side is on the
Like if if this side.
Yeah,
if this side was on the magnet, would that make any difference?
If this side is on the what? Sorry?
If that was magnet, if this side was on the weighing scale, would it make any difference?
So what you're saying is, let me confirm. That means the magnet looks like that. And that's the wire. That's what you're saying.
Yeah.
And this is the pole P, right? In this situation, again, you must consider where does the force go. So again, let's assume that this is O and out. Let's just assume that, right? So you have this as the B, right? You have this as the I low. So the question is, if we're using my Fleming left hand rule, where does the force point to, right? The force will point to IB. The force will be pointing like that, which will not change the reading at all. I don't think so. You understand? I don't think so.
Okay. Never mind then.
And yeah, right?
Yeah.
So, Austin, how are you?
I found the borders here.
One, yeah, nice. Okay, great. So again, do you know how to handle? Right. So back to them. I was telling you that this guy, right? This guy is the circle minus the line, right? The circle on top minus the line on bottom, right? From this limit, which is 1 and minus 1, to this limit, which is 3. Integrate, right? From minus 1 to 3. This is your minus 1, this is 3. Integrate who? Integrate the circle. In terms of, this is D, going to be D, dy, right? So it's going to be right? I will need this guy, and then minus x equals to y plus 2, minus y plus 2. Okay. Integrate this from minus 1 to 3 dy. Would that be okay?
So the volume of
revolution is this square this square, which I suppose maybe it's useful. This square, pi is it pi outside?
Yeah.
Something like that.
That's all.
For this region, for this, I mean, what else do you expect for this one? Yeah.
Oh, then I find the bottom one separately, right?
And then the bottom one separately. Yeah, I think you have to find it separate. I think you cannot combine it. I think it's very confusing if you combine it.
Okay, how do I integrate the first one?
This thing, right? This thing. How do you integrate this one, right?
Yeah. No, as in just the square root.
Okay, so I'm going to simplify this first. I'm going to simplify this first. So what I have here is this one, 8 over 1 minus 1 square, which is quite easily simplified, but let me just get to that later. So y plus 5, right? Right. Then I'll simplify this as 2 root 2 over y minus 1, right? Minus y plus 5, right? At least I can simplify up to this point. Correct? Yes? Yeah. Right. Okay, then I will simply square this and see what happens. Right? I'll simply square. I will actually...
I can square it first.
No, no problem. No problem. Well, yeah, I mean, you have to square it. You have to square it. Yeah, you have to square it and then think about it. My guess is, however, you won't have much problem. I don't think you have much problem.
Okay, if I square the y plus 2, right, do I have to do the rainbow thing? Or is it just y squared plus 4?
If you're talking about how to make it shorter, I mean, you just lump it this way. Look. You have to lump it this way. I think it's easier if you just lump this with that. I think. So this whole thing square, right? So just lump it this way. I think even after you square, integrating it piece by piece should not be a problem. I don't think there's a problem.
All this for 4 marks.
Fair enough. Yeah, this is annoying. Yeah, fair enough. The circle equation is annoying. Yep, pretty much. Yeah, pretty much true. Pretty much true. Oh my goodness, I did a wrong thing. Oh my goodness, I'm so sorry. This is like totally wrong. I'm so sorry. It's supposed to be 8 minus. What are we talking about? 8 minus. Why? I'm so sorry. I'm so sorry. Almost led you to the wrong path. Should be like that. Right? And this should be easier.
It's a lot easier.
Yeah, minus y plus 2, which I also did something wrong here again. So just please continue. Go ahead, please. Go ahead. Give it a try. Yankin, are you okay?
Oh, yeah, I'm fine.
Right. So are you prepared for tomorrow's lecture or tutorial?
There's no lecture tomorrow, but I'm pretty prepared for camp, I think.
Right. Very nice. I mean, it is obvious that you're prepared and you will probably enjoy the explanation. The explanation will feel like an answer instead of an additional burden.
Yeah, and I did my math in the afternoon, so I think I'm okay.
Yeah, I'm very surprised you didn't ask math. You okay?
Oh, math is we're doing differential equations, so only going through I think 3 questions tomorrow, and all the definite integral stuff I asked you last week on Wednesday, remember?
Right. So currently, so was... no problem with ODE. Currently, a differential equation.
Not yet, because the lecture on Thursday went until where we prepared. We were very prepared on a long time.
Okay, then let me tell you something about DE. So most probably then you haven't reached the DE where you have to actually read the question and interpret the question. It's a reading comprehension. A DE question is usually a very long word problem, which you then have to interpret the sentences into your starting. That's basically your first step. You have to write down the mathematical sentence from the super long paragraph. You haven't reached there, I'm guessing.
I don't think so. I don't understand that.
Prepare your lecture based on that. How am I supposed to read this long paragraph and then suddenly arrive at basically the first step? Okay, you should prepare based on that and you should focus on understanding that. That's all I'm saying. Okay, Ken?
In any case, the next the next differential equation lecture will be on Thursday. So
on Wednesday we can talk about it. Good.
Yeah.
Good. Anything else that you want to ask?
No, I don't think so.
Right. Very good. Very good. I'm happy that you're tired in a good way. I will strongly suggest, but then again, you're resting very well, so nothing to complain there. Maybe just one thing, as we're at this sauna, I don't think you should be adding the quantity of your study time. I don't think so. I think that's bad. I think you should always strive to maximize the quality. What I mean is you should be maximizing this evening time, not increase the time, and you should always be maximizing the school time. You should not be increasing the quantity of your study time at all. Right?
Okay.
If you go there or you feel some need there, we can talk about it. What I'm trying to say is once you do that, you will get the bad kind of tiredness, is what I'm guessing. Okay? Because you're not at your prime. Okay? All right. So I'll see you on Wednesday.
Yeah, okay.
Good job. Bye-bye.
Thank you. Bye-bye.
Austin, are you okay?
Yeah.
Okay. I'm trying to be strict to see whether 1.5 hours is enough. So would you mind if I stop here first?
Oh yeah, can. I'll just do this.
Right.
If I have any question, I can just text you, right?
Of course. Do I still owe you anything?
No. The previous maths question.
Oh yeah. Okay. I'll think about it. Maybe I'll find it. Maybe I.
Okay.
I'll see you on Wednesday.
Okay.
Bye-bye.
Bye-bye.